on arrays, on algorithms that we will use them to solve problems relevant to array. And in this series, we will cover the two-pointer technique, sliding window, prefix sum, Cadden algorithm, hashing, sorting. Actually, for sorting, I will create a separate series of videos because there are different sorting types. So for each of them, I will create a separate video, and binary search. Today, I will focus on the two-pointer technique. Most of the time, when you are working with an array, you need to traverse the array and go through each member or element of the array in order to look for something specific based on some specific conditions. But most of the time that happens with one pointer. You start either from the beginning or end. But sometimes we need to have two pointer. It makes our job easier and faster. Or sometimes we have to use two pointers to solve a problem. There are many problems that you can use that you can solve using this technique. However, right now I will solve one problem that is from LeetCode, container with the most water. It is a very famous question on LeetCode. You may have already seen this. However, today we will use this. We will solve this using the two-pointer technique. So first, read the question. What does it say? It says you are given an integer array height. Okay, for example, this one, an integer array. That every array shows height of a line, and it is named height. Of length n, well, length n, it can be any number. There are n vertical lines drawn such that the two endpoints of the ith line are I0, this one 0 and I height I index and height I. Height I means that line that and in this array that means for example height 0 means number 1, height I means height, for example number 1 means 8. So now it says that find two lines that together with the x-axis form a container. So now you can see that every two lines, for example this line and this line, make a container with this x-axis, and we can add some water here. But here is a problem, here is a condition. Form a container such that the container contains the most water. So there are all these lines represent an element of the array. So now you can form many container using these lines. However, now we need to find that two lines that form the largest container. So technically that means calculating an area between the two lines and the x-axis. So now we will use our geometry knowledge and calculate the area between all these lines and the x-axis, between all the containers that are created with the x-axis. For example, once we will calculate this area, once we make, for example, calculate this area from using the first line and the last line and this area. For example, the y is this x-axis, the space between this first line and the last line, and the height is the height of this shorter line. If we consider the shorter line, remember that, because if you consider the larger line, that means if you add more water, so it flow outside of the container when it goes higher than the shorter line. So now here we need to use two pointer. One should point to the first element, and the other one should point to the last element, and keep calculating the container the area which is formed between these two lines. So now, so geometrically, you know that when you calculate an area, you need to have height and width. So now, in order to find the maximum area, right now let maximum area, max area, right now it is 0. So now let's create two pointers. One should point to the first node, first element in the array, for example number 1, and one should point to the last element in the array that represents this line. Let left equals 0. We will use them as index. For example, index 0 point to this one, and index, for example, this one 0, 1, 2, 3, 4, 5, 6, 7, 8. So there are 9 elements. The length is 9 minus 1, 8. So we can say let right pointer equals this array which is passed here. The name is height, height, height dot length, length minus 1, because the length of this is 9. We say minus 1 because they represent the index of the elements in the array. So, and when you use the two pointer technique, you keep processing, for example, either from the left side we keep going ahead, or from the right side you keep going ahead, and you keep continuing this until left is smaller than the right one. The moment that the left becomes equal to the right, or that cannot become actually greater than the right, but if it becomes greater than the right, that means you have not reached a solution and something may have gone wrong. So you have to process that and check what has gone wrong. So now you say while left is less than right, every time you calculate the area between those two lines. So for example, at first when you calculate this area, so you need to get the height and width, because when you calculate an area you need to have the height and you need to have the width. So now that you need to calculate between these two lines, the first line and the last line, you should have this space, the width between these two, and the height of, so of course you consider the shorter line. So now you can get let height, I just say h. So height, you need to get the length of shorter line. So of course between this line and this line, it is the shorter one, so you need to get the minimum of those two. So you say math.mean height, height of left, comma height height right. So here it brings the line of the height of this line, and also you need to get the width. So if you consider the x-axis here from 0 up until here, so you need to subtract this space, and the remaining space is the width that you need. So you say right minus left. It represents the right and this one represents the left, so you minus left it, and this way you get the width, the space between these two lines. And now you need to calculate this area. So you say let area equals height by width, and anytime that you get one of these local area, you need to check it against the max area, because when you get the max area, you need to store that in the max area. So max area equals math.max between max area and area, whichever is the maximum will be stored in the max area. So at first time when you calculate the area between first line and last line. So you have to keep processing toward the inside, either from the left or from the right. And how you make that decision? So of course you need to go from the shorter one to the larger one. For example, here it doesn't make sense to calculate using this shorter line, because of course it keeps the smaller area. So we are looking for the larger area. That means we have to ignore this small area, and we have to keep processing, going or moving toward the larger area. So that means if the left is small, we have to we have to move one step forward. But if the right is the small one, we have to move from the right side to inside. So we make a comparison between the first and the last. We say if a line left is less than the line right, if height left is less than the height right. So if it is less than this, we have to move to the next line, left plus plus. Otherwise, in some case, for example, when you come in the next step that we calculate this one and this one, so this is the shorter line. So this time we keep processing toward the inside from the right side when you calculate this line and this line. So now say in that case right minus minus. Okay, so now that we checked here, the condition was true. That means the line left was shorter than the line right. So left moved from this part to this part. That means from first element to the second element. And this time again, so left it was 0 when we said plus plus. Now left is 1, right is still 8. So again 8 is greater than 1. So that condition is true. Again, it keep processing the calculation. So now it gets the height between this line and this line. So we need to get the minimum, the shorter line. So this time it gets the height of this line, which the height of this line is 7. And right, so right is 8, left is 1. 8 minus 1 become 7. So that means the width is 7 and the height is 8. The height is the height is also 7 actually. The height is also 7 because we got the shorter one, and the width is also 7 because we said 8 minus 1, 7. So now this time that we say 7 times 7, it becomes 49. And when we check here, this time, earlier the max area was earlier when we calculated the height was 1, and we calculated the width, so left minus right. Right was 8 and left was 0, so the width was 8 and the height was 1. So 1 times 8, it was 8. So earlier it was 8. Now this time it is 49. So of course 49 gets replaced with number 8. Now the max area contains 49. And now we have to keep processing and we have to move forward. So this time we check, is the height left less than the height right? So we say height left, it is 8 but height right, it is 7. That means this condition doesn't meet this time. It is not true. So this time right moves forward. So right comes from this line to this line. So it keeps processing until the last line, and at the end it gets the maximum area. So at the end we say return max area. Okay, now let's run this. Yeah, both cases passed successfully. So it was that much easy. uh, like when you look at this example, you need to visualize the problem and you need to use your knowledge. Then you can easily come to a solution. And now that you know two-pointer technique, you can easily solve this kind of problem. I hope it was useful. If you have some questions in any part, add them in the comment. I will check your questions and I will answer them. However, until the next lesson, have a nice time.